Okay, so we are going to start, as I said, we are doing 3 lessons in a row on exponent laws. The first 2, very easy, very elementary. The third one starts to get a little woo, but you'll be fine, okay? The key here is if you don't really understand lesson 1, you're not going to understand lesson 2, then you're not going to understand lesson 3, because they all build on top of each other, okay? We're going to start with the first one with a review of what exponents are. All right, now you already know this, so you don't have to write it down if you don't feel you need to write it down, but I'm going to write it down anyway because solid foundations are key. So we review what we know about exponents. We'll use numbers. 3 squared. Tell me everything you can about that construction. Talk to me. Jack.
Well, the base is 3.
The base is 3. How do you know that?
Because it's the number, the bigger number or the one that's closest. I don't know how to explain it.
Okay, no, that's fine. You know it because it's the bigger number. Right? It's written on the line. I don't care, right? That's how you know it's the base, right? Okay, what else do you know about the base? Jack?
Well, that's the number you use, so like, since it's 3 squared, then you do 3 times 3.
Right. The base is what we multiply. Can anybody think of anything else about the base? Because this part of the notes is, I'm going to do the joke again, is all about the base. Amshiman.
A base is anything that is attached to the left of the exponent.
Nice. Now see, that's going a little bit further, right? Amshiman reminds us that it is anything left of the exponent. Does anybody have anything else they want to add about the base? Sam? Okay. Are we cool with the base? Right? Okay. I'm going to ask you a question. Must the base be a number?
No.
It can be a variable. Must the base be a whole number?
No. It can be a fraction.
Fraction or a decimal, because the base is anything. Okay? Awesome. Now, what is the exponent? Jack.
The exponent is like the littler number or the number to our right of the base.
So what is it in this case?
2.
2. And what do we know about it? It's what we call a superscript, which means it's small and it's written above the line. Okay. Do we know anything else about the exponent? Taylor?
We know that the exponent is the amount of times you multiply the base by itself.
The amount of multiplications. Notice I did not say it is the value of the multiplication, right? Because that's different. Okay? Now, that is exponential form. How many other ways can that be written? Late. That is also 3 times 3, which is what?
9.
No.
Oh.
Sam. Yeah. Or, right, repeated multiplication, or expanded form. Amshiman.
That's the standard form of the answer.
Okay, then we have 9, which is standard form or evaluated. Is everybody good?
Yeah.
Okay. Now, there's a couple of things that we need to remember about exponents, right? Is 1 an exponent? Or I shouldn't say is. Can 1 be an exponent?
Yes.
When? Can 1 be an exponent? Sam? Right. So 3 has what exponent? 1, but we don't write it. So I'm going to write it there in highlighter, 1, because it's not really there. Right? We don't write it, but it's there. Can 0 be an exponent? What is 3 to the 0? 1. The exponent, though, would still be there. Is everybody cool? That's all the background you need. We are going to go on now. Everyone is good? 100%? Okay. So the first one we are going to do, the first exponent law, is called the product of powers. Now, Jack, I have 2 children at home, so I have what is called parental patience. I can take stuff like that for a long time. Your peers cannot. And I have heard them ask you nicely a few times to stop doing that. Then I have heard them ask you meanly a few times to stop doing that. I firmly believe in the needs of the many outweighing the needs of the few. Since more than one person has asked you not to do that nicely, that means more than one person needs you to stop doing that. Okay? Thank you. Product of powers. What math, because there are only 4 maths, what math is product? Multiplication. So this must be a power times a power. That's what we are looking at, okay? Now, there is something you need to know. This is with the same base. Highlight that. Put a cloud around it. Put a star by it. Underline it. I don't care. But be aware that this applies when the bases are the same. So, we are going to, as always, start with a specific example, and then we are going to expand that specific example to a universal truth. Okay? Let's start with the specific example. What is the power that is already written on this page somewhere? 3 to the second. 3 squared. Agreed?
Yeah.
Excellent. Now, do I have a product of powers yet?
No.
No, because I only have one thing, yeah? I had to multiply it by something. Times. Now, it's got to be the same base, so what's my base? 3. And let's make our exponent 3. Now, what does that expression mean? Blake. Right, and what does 3 squared mean? 3 times 3 times, what does 3 cubed mean? 3 times 3 times 3. Which means, what has now happened to 3? Amshiman.
It's being multiplied 5 times.
It is now being multiplied 5 times. Since that base is repeating, we can now write that as 3 to the 5th. And all of you should already see what the law is. What do? Add the exponents. It's math class. When does that rule apply?
All day, every day.
All day, every day, forever. So let's write it down how we would write it if we were applying it to every single number, not just 3. What would it look like? What do we use in math for some number?
X or Y or something.
X, right? X has a power,
Unknown power.
an unknown power. So what do we use?
Y.
Another variable, yeah?
Yeah.
I'm going to use A. I like to use the other end of the alphabet. X to the A times X to the B is what? X to the A plus B. Does everybody have it? We've proven it once, so we're going to leave it alone, yeah? Now, let's just, don't write this down, just let's have a look at this situation. What is 3 times 3? 9. What is 3 to the 1 times 3 to the 1? 3 squared, which is 9. Picking up what I'm putting down? What is 3 squared times 3 to the 0?
9.
It's 3 to the 2 plus 0, which is 3 squared, which is 9. Is everybody good with law 1?
Yeah.
Okay, let's do some work with it. Go. What's that one? 5 to the 3 plus 4, which is 5 to the 7. What's B?
Negative 6. With brackets.
2 plus 3. Why do I need those brackets, Leighton? You're not Leighton.
Because if you remove the brackets, it's going to be a different.
Yeah, if I remove the brackets, it ain't going to be right, is it? And what is C?
7 to the 7 cubed.
7 to the 2 plus 1. Why is it 1? Because what lives right there that we don't write?
1.
1. Where else in this expression should there be 2 1s that we don't write? Sam?
The 7 squared, like 7 times 7, like 7 times 1 and 7 times 1.
Okay, there's 2 other 1s. Amshun.
The 7 over 1.
These should be 1s in the denominator, shouldn't they? But we don't write them. Just to prove to you that there's lots of examples of times when we don't write the number 1, but it's actually there. Everybody good?
Yeah.
Excellent. Sim sim salabim. Do that. You got 5 seconds. Go. 5, 4, 3, 2, 1. Done. 9th, 7th, negative 3 to the 5th, 10 to the 6th. Everybody can do it, right?
Yeah.
And now all of you should be saying, really, Myers? You said this was going to be difficult. Don't be that way. Stop trying to scare us. Durr. Guess what the worst test in my Honors 10 class was last year?
Hours.
Exponents.
They did the work.
No, that was of the 8 unit tests they did. The worst test they did was exponents.
Oh, great. That got us very well.
All right. Turn the page over.
Oh, yes.
More review. All right. Excuse me. How rude.
Who did that?
Me.
Oh, that's even on YouTube.
3 cubed times 3 squared is what? Really? Don't tell me the answer. Tell me everything you need to do to get that answer.
3 to the power 3 times 3 times 3.
To get 3 to the 5th. Yeah?
Yeah.
Okay. Now, I want to take this moment to show you your calculator. How many of you know how to do exponents on your calculator?
No.
So not everybody. Okay. Look on your calculator right now for one of the following 5 buttons. It is either X with a little y, or it is Y with a little x, or it is X with a little blank, or it is this little mountain. It's called a caret.
Oh, I have it.
It is one of those 4. I said 5. I'm trying to remember if there's a 5th or if there's only the 4 ways. That should be it. One of those 4 should be on your machine. Jack.
I got a fifth that says X is a little 2.
No,
That means
that's squared. Okay? That will only square. These will do every exponent.
oh, okay.
Okay? And this is how you do them. It is base, then your exponent button. I'm going to use the little mountain, the caret, because it's the easiest one to draw. Then your exponent, then equals. That is how you do exponents on a calculator when we are evaluating. So everybody make sure, what is 3 to the 5th? Really? Jack?
3 times 3 times 3.
Yeah, what does it evaluate out to? Yeah, okay.
My calculator just says E with a caret and then a bracket.
No, that's still not the right thing. My bet is you have an x to the y or a y to the x.
I got E to the X.
Nope. X to the y or y to the x. No e's. E is different math. You'll get to that in grade 11. So what is 3 to the 5th? Pardon? 243? Sam, is this your calculator?
Yes, it is.
Thought so.
Oh!
Hey, he's a Bangor superstar. He's going to catch it.
I didn't get
Whatever. I'm a Frisbee golf superstar. Yes. So we can all make our calculators evaluate, right? Everybody? Okay. No matter what the base is, no matter what the exponent is, let's make sure what is negative 2 to the 6th. Amshman?
negative 1 times 2 times 2 times 2 times 2.
So what does it evaluate to? I want you to use your calculator. Yes.
Negative 64.
Negative 64. What is negative 2 to the 6th? Make your calculator show you positive 64. I know that you know from yesterday when we did our theory that it's positive, but make your calculator show you. What do you got to add here to make your calculator do it right? Brackets. Right? 64. Okay? Everybody good?
Yes.
Yeah? 100%?
Yeah.
Okay.
101.
So that's our review, yes?
Yes.
Now remember, this is a universal truth. Agreed?
Yeah.
So, smart kids, we've done product of powers. What is next? Quotient of powers. What math is quotient? Division. You guys are smart kids. We're going to use this white space up here to do the reason. Then we're going to write the law down here. Okay? First, we're going to do the reason. So I have 3 to the 5th divided by 3 squared. How many different ways can I write that? Jack, give me another way.
You could do 3 times 3 times 3 times 3 times 3.
You could do 3 times 3 times 3 times 3 times 3 divided by 3 times 3.
Or make sure you put a bracket.
Is everybody okay with that?
Yeah.
Okay? To be perfectly right, I should have a bracket, but it's not needed because trust me, I'm going somewhere with this. How else can I write division? Amshman.
3 to the power 5, fraction bar, 3 to the power 2.
3 to the 5 over 3 to the 2. That is also division, is it not?
Yes, it is. Yeah.
Excellent. Is there a third way I can show division? Sam. Standard form. I could evaluate these and then do the same, divided by or this, yes? Yeah. So I could also do 3 to the 5th, which we know is 243, over 9, couldn't I?
Yeah.
Is everybody good?
Yeah.
Everyone's okay still, right? This is nothing new, yeah? Okay. Is there another way I can show division? Leighton.
3 times 3 times 3 times 3 times 3 fraction bar 3 times
I could do expanded multiplication as a fraction.
It's 3 to the power 2.
Yes, of course it is, but I'm going somewhere with this. Is there another way to show division?
Maybe. Could be.
Amsham? Oh, I did 3 there, didn't I? Yeah, sorry. Michael?
you can subtract the 2 from 5.
Yeah, that's not showing division. That is where we're going. Like you guys have already seen, you know where we're going because you're smart kids. But I want to know if any of you can recognize the last way to show division. Sam? Jack? I'm going to write it in green. This is also division. 3 to the 5th times 1 over 3 squared.
Flip it.
Because remember, dividing is the same as multiplying by the reciprocal. Everybody cool?
Yeah.
Now, what Michael and Amshman have already said and what everybody else has noticed, what happens to 3 and 3?
They divide. They cancel each other out.
We always say cancel, but what do we really mean?
Divided by itself.
3 divided by 3 is 1. And 1 times anything, the 1 doesn't matter, does it?
Yeah.
Cancel, cancel. What's left? 3 cubed, which we evaluate as 27. So, what is our law? If we have a power divided by a power, which is also a power over a power, which is also a power times the reciprocal of the same power, then what do I do with the exponents? I subtract them. What is the other thing I need to remember when I am doing this?
Same base.
Same base. Same base. And highlight. Mrs. Bad Crumble Cloud. Arrows, underline, don't care. So,
I don't like that trouble.
what do we got here? 4 to the 5 minus 3 to get 4 squared. Do I want that to ever be written as 16?
No. Not at this moment.
Not at this moment, only if I ask for what? Evaluated. Or starts with an S,
Solve.
ends with an M, has standard 4 in the middle.
Standard.
Standard form. What's this one?
That with a bracket.
Make it equal to the power 5.
Gouda?
Great.
Great. 5 seconds. Go.
Oh god.
6.
Who knows?
Everybody Gouda?
Great.
Gouda?
Great.
Who's not Gouda?
Now I'm Buddha.
Okay. Now, does BEDMAS apply to everything?
Yeah.
All day, every day.
Even when there's a bucket of bases and exponents, do I still apply BEDMAS?
Yeah.
Of course I still apply BEDMAS. So what do I do here?
Oh, you multiply the first two squares.
Oh, and
2 is my base. And what do I do with the exponents?
Add.
2 plus 3, then what?
then you subtract it by 4.
Minus 4, which is what?
1.
2 to the 5th minus 4, which is 2 to the 1. Would I ever write that?
No.
Only if I wanted to look unintelligent, because we write that as 2.
So, so you don't, so you can put the 1, but it just makes you wrong.
It's not right.
It isn't?
It isn't right. You don't write a 1. You use a 1, but you don't write a 1. So look at the next question. What I just said, how does that apply to the next question?
Oh, there's no 1.
There's no 1, but
But there's no 1.
there is a 1 because you use a 1. So this is negative 2, 5 minus 3 plus 1, which is negative 2 to the third.
Yeah.
Right?
C.
Now, evaluate that. You can use your calculator or you can do it in your head. Negative 8. Because it is negative 2 times negative 2 times negative 2. Negative times a negative is a positive, times a third negative gets me a negative. Is everybody Gouda?
Great.
All right. Now, believe it or not, that is some pretty powerful math. The way we teach it is so easy. Add the exponents. Subtract the exponents. But what is happening there is tremendously large numbers can be broken down into nothing, right? Because exponents are how we write those tremendously large numbers, correct? 5 to the 7th is an amazingly large number. But 5 to the 7th in exponent form
It's tiny.
is easy peasy, right? So, we're going to stop there. You guys are going to go and grab page 76. And at about 2:05 to 10-ish, I'll give you back your tests. Okay? Sam. Only what is the power and order of operations? Okay? Everybody Gouda?
Let's go with identifying the base, the identifying the exponent.
Yep.
Bye.